This video is going to have a look at how to apply arithmetic sequences to simple interest. Remembering simple interest is where we earn the same amount of interest each year during the investment. So when we're using simple interest with arithmetic sequences, we can use the general rule, but we can also make a couple of adjustments. So the first adjustment is, instead of using T1, we're using a T0 value. That's because we have a starting value at the start of the investment, but our first term in the sequence is going to be the value after the first year. So because we're using a T0, we don't need our -1 after our n. So that's then going to become just an n value, and we can move d in front of the n if we want to. And because we're using interest and we're looking for the future amount, we can use a instead of t. So the rule for interest can be an is equal to a0 plus dn, with d being the amount of interest we are earning each year. So let's have a look at an example of how we can calculate interest using an arithmetic sequence. So in the example, Danny is investing 20,000 into a bank account. He's going to be paid simple interest at a rate of 5% per annum. And we want to set up a recurrence relation to display this information to begin with. Before I can set up that recurrence relation, I need to be able to determine what my common difference is going to be. Now the common difference amount is going to be the amount of interest per year. So that's going to be $20,000 times by 5%, or 0.05, which is equal to $1,000. So each year, Danny is going to be paid $1,000 based on his initial investment value. So in some questions, they may tell you what this amount is. In other questions, they're going to give you the percent, and you have to calculate it yourself. So for this question, our D value is equal to 1,000. So that gives me enough information to go ahead and write the recurrence relation. So A0, my first term, my starting term, is going to be 20,000. My next term is going to equal to my current term plus $1,000. So my recurrence relation is going to be A0 is equal to 20,000, AN plus 1 is equal to AN plus 1,000. Now, I could use that recurrence relation to be able to write down the numbers within the sequence or the balances at the end of each year if I wanted to. Alternatively, I could write a rule that will allow me to calculate the balance in a specific period of time. So that rule would be AN is equal to my starting amount, so 20,000 plus 1,000 times by n, being the number of years into the future. So now that I have that rule, I can have a look at C and D. So C is asking me to find the value of the investment after 5 years. So that's going to be when n is equal to 5, what is the value of the investment? And I can find that by substituting it into the rule. So it's going to be A5 is equal to 20,000 plus 1,000 times by 5, because it's 5 years, which is going to be 25,000. So the value of the investment in 5 years' time is going to be $25,000. The interest amount, if it was asking me to calculate the interest, would be 25,000 minus the original 20,000, equaling $5,000. So just remember that you are finding the future value of the investment, you're not finding the interest amount. And if the question is asking for the interest amount, you have to do that additional calculation. So having a look at the last part of the example, if Danny leaves the money in the account, after how many years will his investment be worth 30,000? So I can use the rule again, AN is equal to 20,000 plus 1,000 N to be able to do that calculation. But this time I'm going to substitute in AN is equal to 30,000, because that's the value of the investment in the future that I am looking for. So 30,000 is equal to 20,000 plus 1,000 N. And that gives me an equation that I can go ahead and solve, because I've got one unknown value. So starting off by getting rid of the lonely number, so minusing 20,000 on both sides, So that leaves me with $10,000 is equal to 1,000 N. To get N by itself, I need to divide both sides by 1,000. So that leaves me with an N value being equal to 10. So finishing off by answering the question, Danny's original investment will be worth $30,000 in 10 years' time. So that's an example of how we can use arithmetic sequences to be able to complete simple interest calculations.